Now you may have seen sequences in calculus before, but we're going to start off by formally defining what a sequence is. A sequence is a function whose domain is the natural numbers, or could be any subset of the natural numbers. And unless specified, the codomain or range of that function is going to be the real numbers. All that's saying is that our sequences will be sequences of real numbers. Now, given a sequence, which we're writing as the function f mapping the naturals into the reals, the nth term of the sequence is written as f of n. It's a function after all. Or we could just write f sub n. And note, in a sequence, terms may repeat. That differentiates a sequence from a set. A set, elements don't repeat. Here's an example, 1, 2, 1, 3, 1, 4, dot, dot, dot. In fact, in this sequence, all of the odd index terms are the same number. So the number 1 shows up an infinite number of times. One other thing that differentiates a sequence from a set, we just mentioned that elements are allowed to repeat in a sequence, and in a sequence the order absolutely matters, whereas a set, it doesn't matter. Here's how we might define a sequence. This notation here defines a sequence of ANs. In other words, since n is going from 1 to infinity, the terms in the sequence would be A1, A2, A3, and so on. Another way of writing it, it's an equivalent way of writing it, A sub n, where the index n is all the natural numbers, which means it's 1, 2, 3, dot, 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 all the way up to infinity. And let's just say, for example, we're defining this to be 1 over n. Let's write out the first few terms of that sequence. Again, n goes 1, 2, 3, dot, dot, dot. So n starts off being a 1. 1 over 1 is the first term. Then we move up to 2. N is 2. So the second term is 1/2. The third term is 1/3. The fourth term is 1/4. Dot, 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 and so on. This is a very, very commonly seen sequence in mathematics. Frequently, just as shorthand, I might just say that defines the entire sequence, although I would need to state that for all natural numbers n. This is just a shorthand notation. The second example, Bn, is defined with using this expression. So, if we want to write out the first few elements, we're going to start off by n equaling 1. When n is a 1, then the exponent n is 1. We end up with -1 plus 1 over 2, 0. When n is a 2, well, -1 squared gives us a 1. So we get -1 minus 1, which is -2. -2, over 2, which gives us a -1. And as you can see, when you raise -1 to the natural numbers, for all of the even natural numbers, -1 raised to the n is 1. For all of the odd numbers, -1 raised to the n is -1. So this is just going to repeat. And again, for shorthand, I could have just defined the sequence to say Bn is -1 minus -1 to the n, all over 2. And then I would have to specify, of course, for all natural numbers n.